Good morning.
Hi. Good
Good
morning,
morning.
Simon. How are you?
I'm very well. How are you?
Fine. We're here speaking while we're waiting you. Here we're speaking about Java and how its version's going, and we put a poll in the chat like which version of Java do you use, and obviously there is no answer, no response about Java 16. A lot of response about Java, like more or less equally 8 and 11.
Yes.
So what do you think about these Java versions and its migrations?
Yeah, I mean, it's interesting to see because obviously there was a big change from, well, really sort of Java 9 onwards with the switch to the 6-month release cycle, and also the fact that Oracle changed the licensing terms on the Oracle JDK. So we've seen quite a lot of people staying on JDK 8 because that works very well and they're very happy with that. But we've seen sort of a gradual migration to JDK 11 because that's the current long-term support release. And then obviously we'll get JDK 17 in September. That will be the next long-term support release. So I would expect to see a lot of people make the move to 17 once that comes out. Although, you know, it'll take a few months for people to start doing that. One of the important things, and I'll kind of come back to this in my presentation, is it's important to test against the versions as they come out, because the 3 years between long-term support releases, that's a lot of changes. So the cumulative effect, you need to make sure that your applications work on 17 and 11. So taking all the different changes into account and going through that gradually is a good idea, even if you're not deploying them in production.
Yeah. Thank you for the answer. So Java 16 was released just like few weeks ago, and there was a big problem with Lombok, for example, because they make some critical changes, let's say. So Lombok was one of the libraries which stopped working. Of course, at the moment they have patch which makes it works, but like anyway. So it looks like the Java 17 may be as breakable as Java 9. So it took a lot of time to promise people that they may migrate further for Java and not be afraid of that, but won't it be a problem with Java 17? What do you think about that?
I must admit, I'm not familiar with. So, what was the problem with Lombok? What actually caused? What change was it that made that break?
They actually used several resource bundles that are internal of the ComSun package, and that was the problem, actually.
Okay, yeah. So you see, this is the problem, is that once you start stepping outside of the public interfaces and the public parts of the JDK, then you are potentially opening yourself up to problems. And so, I mean, yes, we saw with JDK 9 the whole issue of the encapsulation of the internal APIs that was suggested and the loss of things like sun, misc, unsafe. That caused a lot of discussion, and the OpenJDK developers obviously took a step back and said, okay, we're not going to do that. And so they left sun, misc, unsafe available, and things like Spring could still work and stuff like that. I think the move to JDK 17, the number of changes from the internal perspective are quite small. So, okay, Lombok got caught out by that. But I think for most applications, you won't see a problem. Certainly not in the way that modularity has changed things from JDK 8 to JDK 11. I think the changes from JDK 11 to JDK 17 are far less substantial in terms of general applications. So I wouldn't really expect to see many problems there.
Okay, that's promising. if you don't see any problems, that's really promising.
I wouldn't say I don't see any problems, but I see less potential for problems.
Okay, that really do make sense. Okay, so could you please share a couple words? What would be a talk about, like for our audience to be prepared?
Right. Yes. So I actually changed the title ever so slightly, because the title that I had was JDK 16, What's Next in Java. But as you say, we actually have the release of JDK 16, so I've changed it to What's Currently in Java. And so what I'm going to be going through is really sort of talking about JDK 16, because JDK 16 is quite a number of changes which build on things from like JDK 14 and JDK 15. And if we look at some of the new features like records, for example, that started in 14 as a preview feature, it continued in 15 as a preview feature, and now in 16 it's actually part of the standard. So I'm going to talk about what records mean, how useful they are, and we'll go through all the language changes and things like that. So it's really covering what we've got in JDK 16 now and the good things that people can take advantage of. I think as well that this is a useful session from the point of view that obviously with 17 coming up as a next long-term support release, it'll help people understand some of the things that they can use when they get to 17.
Yeah, I really hope that it will be useful for guys, because I see I see a lot of videos everywhere, like what's new in new Java version, but I don't really think that a lot of people use these features. And I think that when they will come to these features, it will be like, what's new here? Records, what's that? Like how to use that? So yeah, I really hope that it will be useful for everyone who would see this talk.
That is the future actually for Java, and that's why it have to be adopted one time, because nowadays everybody are talking about the things, how Kotlin, for example, is beautiful, or how any other language is beautiful, but to adopt it on Java, they have to migrate to the further versions, and it just means that if you want these new features, just migrate to it and get it actually, because it is already in Java. Yeah.
Yes. I mean, one of the things that we've seen quite a lot over the last few years is that people like Brian Gertz, who's the chief architect on the language side of things, I think he's doing a fantastic job in terms of looking at what's available in other languages. So things like Kotlin is a good example, and saying, how can we bring some of those features into Java to, as he describes it, take some of the rough edges off some of the coding that we do in Java at the moment, because Java's a great language, been in use for obviously 25 plus years, and I remember James Gosling describing it as a blue collar language. It was designed to get the job done. It wasn't sort of an academic language. It wasn't an exploration of things. It was about getting a job done, and that's worked really well. But there have been a few cases where as we've seen, we can take a little bit of change and make it a better language. And certainly, even going back to JDK 8 and the introduction of lambdas and streams, bringing a slightly more functional style of programming to the language, and then things like more recently records is a great sort of addition to just make life easier for developers.
Regarding life of developers easier, just a post from yesterday, Microsoft start again working with Java closely, and they say on Twitter that they create their own JDK for Azure, which would be like the main for Azure. And even James Gosling posted like, Microsoft, welcome back to family. Like we have something in the past, but now you're back. So what do you think about that? Microsoft again with us.
Yes, it's certainly an interesting turn of events, isn't it? Because as someone who's been in the Java area for right from the very beginning, I remember being at Sun Microsystems when we went through the whole issue of Microsoft and their approach to Java. They had J++, and they did various things like that. And in those days, Microsoft was a very different company to the one it is today, and that what they wanted to do was to kind of help them use Java to advance their business. What we're seeing now is Microsoft being involved in the OpenJDK project. So it's an open source project. They're being involved in that. They've already started making contributions. If you look at the fact that they helped on the port for Windows on the new ARM64 architecture. They've done some other bits and pieces there around some of the garbage collection stuff, because they've gone out and they've hired people like Monica Beckwith. They've got Martin Verberg, who was the guy who started the Adopt OpenJDK project. So they've brought on some good Java people, and now what they've decided to do is to go down the route of creating their own distribution. So it's important to get the subtlety of what that means. It's not that they're doing their own Java. They are doing their own distribution of OpenJDK, and it will pass TCK, which means it is exactly the same in terms of Java as you get from Oracle, as you get from Azure, as you get from Amazon, Red Hat, and so on. So it's good from that perspective that they're following OpenJDK. They're providing another distribution. Really, for them, it's primarily targeted at the Azure cloud. As you said, they have their users who want to make use of that. In the past, what they've done is use our Zulu JDK, They've made the decision now that they want to create their own to keep everything in-house, which makes a lot of sense for them. But it's good because it just broadens the appeal of Java, make sure that there's more distributions. So absolutely great news. Like it.
Okay, that's really nice. Thank you for these answers. So I think we may go to the talk.
Okay.
So yeah, thank you again for this conversation, and let me just share a couple words. So guys, again, we have main Telegram chat, so join it. We have special chat for questions for Simon, so join this chat as well. So there you may post your questions. These questions we would ask to Simon for sure, and then there would be discussion room, so you would be able to ask his question as well. Here in the bottom of our broadcast, you may see hashtag. Use that on Twitter, Instagram, and Facebook. So not to share your participation in our conference. And Simon, good luck with your talk.
Okay, thank you. Right, so let me just see if I can share the screen. Okay, so I hope you can see my slides. Yes?
Yep, we can.
Okay, good. Excellent. Right, so I will get started then. As I said, the title of this has changed very slightly, and it used to be JDK 16, what's next for Java, and now I've decided to call it what's currently in Java. And the reason for that is that we do actually have JDK 16 released as generally available. You can download it from various distributions and you can deploy it onto your machines if you want to. Just as an introduction to myself, I am Simon Ritter. I am the Deputy CTO of Azure Systems. I have been involved in Java really right from the very beginning. I joined Sun Microsystems way back in 1996, pretty much the same time that JDK 1.0 was released, and I followed it all the way through the Sun years. Got acquired by Oracle, spent 5 years at Oracle, and then for the last 5 and a bit years, I've been at Azure, really doing very similar things in terms of promoting Java and helping people to understand what Java's all about. Okay, so let's get started on JDK 16. So the first thing to understand is that this is the 7th release. It's quite incredible to think that. 7th release under the fairly newish 6-month OpenJDK release cycle. And this was something that Oracle announced in JDK 9, that they were switching from several years potentially between releases to only 6 months between each release. And that was going to provide a very distinct schedule, very clear schedule of when we were going to get new updates. So we now know that in March and September, we get a new version of the JDK. Now, obviously, with only 6 months between releases, not all of them are going to be big in terms of the number of new features that you get in those. JDK 16, I would say, is definitely one of the bigger ones. And if you look at the sort of list of things which I went through, then you'll find that there are actually 17 JDK enhancement proposals, or JEPs, in this release. And of those, 3 are incubator modules and 1's a preview feature. Now, that's quite important because this is something that's new in terms of the last three years or so that has been possible as a result of this faster 6-month release cadence. What we now have is the ability to include features into the Java platform, but without making them part of the standard straight away. And the advantage of that is that by doing that and not making them part of the standard, people can try them out, people can test them and provide feedback so that if some changes are needed, then they can be integrated and then it can be made part of the standard. So it's really sort of allowing people to give their opinion on these things. One thing that's important to understand about both the incubator modules and the preview features is this is not about like beta testing code. This is not about sort of a half-finished feature and gradually developing it. These are fully functional features. All of the work has been done. It's really about, are there any things that need to be changed that have to happen before it becomes part of the standard? And that, again, seems to be working really, really well. I like the fact that we have these things. From an API perspective, again, I went through all of this, and there were 58 new core class elements, so part of the Java SE specification. We've got 1 new class, 3 new interfaces, 2 constructors, 45 methods, and 7 fields. And I'll talk about some of those as we go through. I'm not going to cover all of them. Now, a lot of the changes that we've seen in JDK 16, because this is OpenJDK that we're talking about, it isn't just the Java language, it isn't just the Java virtual machine, it isn't even just the class libraries. It's also changes that apply to the build and the infrastructure that's used to develop OpenJDK. And there are a couple of things that have happened here. First of those is enabling C++ 14 language features. Of course, when you first look at that, you think, well, hang on, we're talking about Java here. So why would I want to use C++ with Java? And the reality is that the Java virtual machine is written in C++. What the developers have now said is that they're going to let people use features from not quite the most recent release of the C++ standard, which is C++ 20, but C++ 14. And I did look at some of the changes there. They're fairly minor, but there's some interesting things that people will be able to use when they're developing JVM level things and contributing that to OpenJDK. Probably the biggest change from an infrastructure point of view is the switch from using Mercurial as the source code management system to using Git, and then migrating the hosting of the OpenJDK project to GitHub. So this is something obviously very, very popular, the use of Git and GitHub. Lots of people host their projects on there, make it available. People are very familiar with the whole process, pull requests and so on. So it's a very sensible decision to migrate OpenJDK as a project onto Git and GitHub. A couple of other things in terms of ports of the OpenJDK. First of those is there's now a Linux port on Alpine Linux. And if you're doing things like microservices and containers, then Alpine's a very popular one because it's very small. You can produce a very small container image, and then by putting Java on top of that, using things like JLink to reduce the size of the JDK itself, then you can produce some really nice compact container images that you can deploy into your cloud. And then the other one, and I briefly mentioned this before we started the presentation, the Windows ARM64 port, which is being done by Microsoft. And again, it's quite interesting to see Microsoft coming back in the OpenJDK project, getting back into Java, very different company to what it was when Java first started out. Right, so let's talk about Java language changes in terms of what we've got in JDK 16. So the first of these relates to how we can determine the type of an object. And so in Java, right from the very beginning, we've had the ability to test an object in terms of its type. We have the instanceof operator. But the way that we do this is not really ideal because it involves a little bit of extra work. And this is one of those situations where what we're seeing with a lot of the language changes is taking some of these rough edges off how we develop code. So let's say we pass an object into a method and we don't know what the type of that is. So we pass it as an object. Then what we can do to test it is to say if obj instance of string. Fine. And then if it is, within the body of that if statement, what we'll do is we'll assign the object to another variable of the correct type, string s, but we have to do an explicit cast to make sure the compiler understands that we're casting object from an object to a string. Once we've done that, we can reference s, we can use the methods on it because it is a string, so all of that will work. The problem with that is obviously that we have to do that explicit cast, and that's a little bit of extra work that we really don't have to do. So what we now have is the idea of pattern matching instance of. And the idea of pattern matching is not about regular expression type patterns. This is patterns in code. And we're going to see more of this as we go forward. So there are some proposals that we'll probably get into at least JDK 17 or maybe later about other patterns in code around things like the switch expression, around the use of records, which we'll come back to a little bit later on. So there's some interesting ideas here. So this is about pattern matching a code pattern. What we're doing here is we're saying, okay, what we want to be able to do is use instance of, but rather than doing explicit cast, let's change it and make it easier. Now we say if obj instance of string, but we specify the name of the variable that we want to assign that to as part of that statement. So now we have the s after string. Within the true branch of that if statement, we can reference s because clearly obj is a string. So we've assigned it to s and the compiler's done that work behind the scenes for us. Now we can call the length method on s and it will work and everything compiles. The obvious thing as well is that in the false branch of that if statement, because obj is not a string, then the scope of s is not valid. So we can't reference s there and we won't be able to call methods on it and it won't work. So that all makes perfect sense. We can take that a little bit further and we can use something like an AND operator. So now we could say if obj instance of string s, and the scope of s now is valid and extends to the right-hand side of that operator. This will work very nicely because we know in the case of the AND operator that we have to evaluate the left-hand side first, and only if it's true will we evaluate the right-hand side, meaning that if obj is a string, s will be assigned, and then we will evaluate the right-hand side to determine if the length of that string is greater than 0. That will compile, that will work, and then we can print out the length. If we were to try the sort of other way of doing things, use the OR operator rather than the AND operator, that would be a compiler error. And the reason being, obviously, that we have to evaluate both sides of the operator in order to determine whether we go through the true or the false branch of that statement. In this case, obj might not be a string, and therefore s doesn't get assigned, but we're still going to call s.length on the right-hand side, which wouldn't necessarily always give us a valid method call, and so we get a compiler error and avoid that problem. Now, some of the scoping of these variables isn't always immediately obvious. So we could do something like this, and we could say if not O instance of string s, so it's not a string, then we return from our method. That means after we've passed that particular statement, we know that s is still valid. So when we can use s for the rest of the code until we leave that method. So now we could do print out s.length. S is still in scope. We do need to be careful of how we use the scoping of those variables, though, because we can sometimes get the situation where we hide the scope of a different variable. Now, clearly, nobody would do this in real life because we wouldn't use just one letter for our variable name. We'd make it a little bit more descriptive. But if we do something like this, where we've got a class and we've got an instance variable called s, it's a string, and we assign it a value of 1. Then we create a method, test my object, pass in an object, use our new instance of pattern matching, and we say if O instance of string s, then within the true branch, s is valid. So it actually refers to O, cast to a string s. So if we print out the contents of s, what we're actually going to print out is the contents of the O object that's been passed, not the string s that's the instance variable of the class bad pattern. We could then modify s, and that will work. So we could append 2 to s, but then when we leave the if statement and we print out s, what we're going to do is not print out 1 followed by 2, or even whatever the object held plus 2. We're only going to print out 1. So you do need to be a little bit careful about the scoping of this, because you can end up hiding things. As I say, that's probably kind of an extreme thing, and I wouldn't expect many people to run into this problem. In terms of pattern matching instance of, that was a preview feature from JDK 14, and then was also a preview feature in JDK 15. What's happened in JDK 16 is it's now been made a final feature. So it is included in the Java SE specification. It means that you don't have to enable the preview features to use it. Prior to 16, you would have had to use 2 command line flags. One is enable preview features, and the other you would have to specify which version you wanted to enable preview features for. They did make 2 minor changes to the way pattern matching instance of works between JDK 15 and JDK 16. First of those is that pattern variables are no longer implicitly final. Now, I think this actually makes a lot of sense, because in the initial design, what they said was that the S, if you like, from our previous examples, that would be then final. So you couldn't modify it in terms of within your if statement. Obviously now it's not implicitly final, so you can make changes to it. And as I say, I think that makes a lot of sense. The other thing they've done, which is kind of interesting, is that they've specified that it's a compile time error to compare an expression of type S against a pattern of type T, where S is a subtype of T. Okay, now you have to read that a couple of times to actually understand what it means, but I'll show you an example. So if we had a method that we define, say, print upper left corner colored point, and we pass in rectangle, and then we do if our instance of rectangle, that will give us a compile error. And I did this on JShell, and you'll see that it says pattern type rectangle is a subtype of expression type rectangle. Effectively, it's a pointless instance of, because if you're passing in a rectangle and then you're saying if R is an instance of rectangle, it's always going to be a rectangle. There is no way it could be anything else. So it's a pointless comparison, and they've now made that a compile time error. The reason I say this is very interesting is because if you look at some of the newer discussions in terms of, I think it's JEP 405 around pattern matching for records, there's an interesting situation where this appears to kind of counteract what they're saying in that JEP, but I won't go into all that detail right now. It's just interesting to look at how that's working. Right, next thing is to look at how inheritance works in Java. So we know Java is an object-oriented programming language. We have the four fundamental ideas of object-oriented, and one of those is the ability to have inheritance so that we can have a type hierarchy. In this example here, what we're saying is we have a class called shape, and then we have three subclasses of that: triangle, square, and pentagon. They inherit the properties and the behavior of shape, and then you can adjust that by adding more properties or more behavior on top of that. The thing about this is that we don't have any control from shape about who, in terms of the classes, can subclass shape. Only thing we can do is turn off the ability of anybody to subclass it by making it final. So if we make shape final, nobody can subclass that. But we don't have any more fine-grained control over that. What we now have in Java is the idea of sealed classes. And again, this was a preview feature that was introduced in JDK 15. So not part of the Java SE standard. As I said, you need to have two command line flags, enable preview on both compile time and runtime. And then for compile time, you also need to specify which release you want to use those preview features for. For sealed classes in JDK 16, this is now in a second preview. So unlike the pattern matching instance of, which is now a final feature, this is continuing in preview mode, and they're making a couple of changes to it. So what sealed classes allow you to do is to control which classes can subclass from a given class. And you can think of the idea of a final class as being the ultimate sealed class, because nobody can subclass from it. One of the interesting things about this is that the JEP is actually called sealed classes, but it also applies to interfaces. And I must admit, when I first read through this, I thought to myself, wouldn't it be better to call it sealed types, since that would cover both classes and interfaces? And so I tweeted about this, and Brian Gertz came back and he said, yes, originally we were going to call it sealed types, but then we decided that since interfaces are technically a class, we'd call it sealed classes. So I learned something new there, that interfaces are technically classes as well. How this works is through the introduction of some new contextual keywords. And this is, again, it's a kind of an interesting little side note on Java, because obviously there are reserved words in Java, ones that you can't use as variable names. So if you take things like int, for example, you can't use int as a variable name. You can't use for, F-O-R, as a variable name because they're reserved words. Over time, what's happened is that Java has required new words that we need as part of the syntax of the language. And there have been a couple of examples where we have added new reserved words. JDK 1.4 introduced assertions, so assert became a reserved word. In JDK 5, we got enumeration, so enum became a reserved word. Since then, what they've tried to do is avoid adding reserved words because that prevents people from using them as variable names, and that can lead to a lot of backwards compatibility issues. So in the past, they've used the idea of restricted identifiers and restricted keywords, so that the identifier or the keyword is only valid in a certain context. Good example of that is local variable type inference that was introduced in JDK 10. So var is now was a reserved type, meaning that you couldn't create a class called var with a lowercase v. Not that you ever would have done, but it meant that you couldn't do that anymore. But you can still use var as a variable name. So you can have var. What they've now done is decide to kind of change that slightly. So they have the idea of contextual keywords, and that just covers all the places where they need to use something as a reserved word, but not have it prevent people from using it as a variable name. In the case of sealed classes, there are 3 of these. There's sealed, permits, and non-sealed. And again, this is one of those things that caused a lot of discussion because it's the first hyphenated keyword in Java, so non-sealed. And because hyphens can't be used in variable names, it's not a problem in terms of backwards compatibility and so on. One of the other things about sealed classes is that they must be in the same package or same module. So there has to be local visibility for the classes that are involved in this structure. How this works is by extending the way that we define a class. In the case of our shape, what we can now do is we can add some modifiers to that, and we can say public sealed class shape, and then we add a permits clause which specifies the classes which are allowed to subclass from shape. So we say permits triangle, square, and pentagon. In the example of our type hierarchy here, all of that will work. We can have triangle, square, and pentagon inherit from shape. We can extend it. That code will compile quite happily. If somebody were to come along and decide, oh, I like class shape, I'd like to use it, I want to create a new one called circle, and they try to extend shape with their circle class, then the compiler will reject that because it's not specified in the permits clause of the class shape. The next thing that's really important is that all of the subclasses that we define for a sealed class must have their inheritance capabilities specified explicitly. So you can't just say, in the case of triangle, class triangle extends shape, and that's it. You need to specify more about it. And there are 3 distinct possibilities that you can use here. First of those is you can extend the sealing of that class. So you can say, using our example triangle, we will say public sealed class triangle, and then we provide another permits clause for a further set of subclasses of triangle. So we'll say permits equilateral and isosceles, and of course it extends shape. So that's extending the type hierarchy with further sealed classes. Second thing we could do is to turn off the ability for any further subclassing. So the traditional thing that we would do, we simply say public final class square extend shape. No other classes can extend shape. And the last one is the one where we see this hyphenated keyword being used. And this is where we effectively turn off the sealing of that class and allow any other classes to extend that one. We'll say public non-sealed class pentagon extend shape, and that means that anybody who wants to extend pentagon can do. There's no restrictions on that. But you have to specify one of those 3 things for any class which is part of a sealed class hierarchy. Contextual keyword humor. I did a presentation on this a little while ago, and somebody kind of pointed this out to me, which I thought was quite funny, which is you can define these variables. You could define int non equals 2, int sealed equals 1. And then you could do this, var equals non-sealed. Or actually non-minus sealed. And so it was just one of those situations where you thought, yeah, you could do that. I wouldn't though, because it just looks confusing. So even if you just put spaces around the minus, that would be better. Okay, next thing, data classes in Java. This is the kind of thing that we use all the time. So we need something as simple as a tuple. We have a point. So we create a class called point. It has two instance variables, double x, double y, which are going to make final. We need a constructor. So we define constructor point that takes those two variables. It assigns the values from the parameters to the instance variables. And then we need two accessor methods that we can retrieve the values of x and value of y. All good, very simple, but it's 14 lines of code just to create a tuple. Again, one of those places where it would be really good if we could take the rough edges off Java. And that's what we're doing with the idea of records. Again, this was something that we introduced as a preview feature in JDK 14. It's now final in JDK 16. A couple of changes that they did make to the specification from 15 to 16. First is that record fields are now really, truly final. What I mean by that is that obviously in the example I showed you, we made X and Y final. So you would think that means they're final fields. Well, they are technically from a language point of view, but you can still change them if you use reflection. Now with records, what they've said is even with reflection, you can't change the values of a record, which I think is really good because it makes a lot of sense. You want it to be final, it should be final. A couple of other things they've done is native methods are now explicitly prohibited from records. That was a minor change that they said because they thought that could introduce behavior that's dependent on external state. And then there's a nice change in terms of inner classes now being able to declare implicit or explicit static members. And I'll show you an example of that in a moment. So how records work is to simplify what we had before. Rather than having those 14 lines of code, now we have one. We simply say record point, and then we use the brackets as effectively like the constructor and the parameters, and say double x and double y and an empty set of braces. The compiler will understand that what that means is effectively a tuple, a record called point, which is a class, has a double x, double y, and creates the constructor and the accessor methods for you, and everything works very happily. But we only have one line of code. We can do a couple of other things because we can use what's called the compact constructor. There may be situations where you want to do something in the constructor that has a little bit more logic than simply assigning the values of x and y to the instance variables. Here we've got an example where we create a record called range, takes two values, low and high. And in terms of the constructor, what we want to do is test whether low is greater than high. If it is, throw an illegal argument exception. If you look at the compact constructor, what we do is we leave out the parameters. There's really no point in having that because if you look at the record definition above, it's already got the parameters that we're going to be passing. So why duplicate that? It's a nice idea. So we can test the low is greater than high, throw the illegal argument exception, and the rest of the code for the record is generated by the compiler. There are some extra things that you need to know about records and how they work. So first of those is in the case of the compact constructor, you can only throw unchecked exceptions. So that example I just showed you with our range, we could throw an illegal argument exception because we didn't have to define it as a throws clause on the constructor. There is no way to do that, so you can only throw an unchecked exception. Checked exceptions, not allowed. Because a record is a class, you can override certain methods of the object class, equals, hashcode, and toString. The other ones you can't, but these three you can. So if you want to define a different way of producing a string representation of your record, you can do that. If you want to have a different method for the hashcode and so on, that you can all do. The base class of all records is java.lang.record. And so that's quite important because essentially a record is a class in the same way that enumeration is a class. It's just a special form of class. And the reality is that because it extends record, that's why it's a special form of class. It also means that you can't have a record that extends another class. It already extends record, therefore you can't have multiple inheritance in that sense. One thing that's interesting is records don't follow the Java bean pattern. So rather than using getX or getY, you simply use X and Y as method names. This is, again, something that created quite a lot of discussion on the mailing lists about this. My personal preference would have been to use the bean pattern, but you know, you can ask 100 developers which they prefer, and 50 will prefer X, 50 will prefer get X, just in the same way that 50 will prefer tabs, 50 will prefer spaces. Of course, spaces is the right answer. Instance fields cannot be added to a record. In our point, we had X and Y that were defined. We couldn't have added a Z unless it was a static field, meaning that it was shared amongst all instances of that record. But you can't add other instance fields which are not defined as part of the record definition, which really kind of makes sense. Records can also be generic, so you can use generic type parameters with your record because essentially it is a class, so there's no restriction on that. I mentioned the idea of being able to use local records, and so being an implicitly static member of a class and a method. So this is a good example here. What we've got is a method which is find top vendors. And so we've got people who sell stuff for us, and we want to determine an ordered list of the people who are selling things for us for a given month. Now, to do that, we will pass in a list of the vendors that we have, which will contain information, and we'll also pass in the month we're interested in. To simplify how our stream code is going to work, we'll create a local record, and that local record we'll call sales, which will have a vendor associated with it and a value, which is how much that vendor sold in a particular time. Now what we can do is we can say, take our list of sellers, create a stream from that, map those vendors to a stream of our local record sales, and we'll put the vendor into that, and then we'll call a method which will determine how much that vendor sold in the particular month we're interested in. So now we've got our tuple with both the vendor and how much they sold. We can then use those tuples, pass it into sorted, and do a comparison based on the sales that they had. So now we order them by who sold the most, map that back from the sales tuple from our local record into the vendors themselves. So now we just have the vendor. We don't need to care about how much they actually sold. Collect it into a list and then return that. So that will have the effect of providing us with an ordered list of our vendors by how much they sold in that given month. And the nice thing about this, as I say, is we can have the local record. We don't have to specify outside of that. We don't have to create a new class or anything like that. And it just makes that code nice and tidy, much simpler to understand. I really like this particular feature in this case. Records can also work with seal classes, because seal classes and we can have interfaces, so that's not a problem. So in the case of example here, we can have a public sealed interface called car, and we can say it permits red car and blue car. And then because that's an interface, we can have our record implement the interface. Can't extend another class, but we can implement other interfaces. So we can say record red car implements car, and blue car implements car as well, and that will work. So it's just combining the features to give us even more functionality. Okay, so let's move on to class library changes, because there are a couple of interesting things here in terms of JDK 16. First of those is adding Unix domain socket channels to the Java API. Essentially, this is something that's been around for a long time. Unix sockets, which is a way of doing inter-process communication on a Unix machine. Wonderful. Used in lots of different places, and it's really handy. The thing is that in the past, because Windows hasn't had the capability to do Unix type socket channels, and I think it was Windows 10 that introduced this. I have to go back and look, but I think it was Windows 10 that introduced this. Because of the write once run anywhere aspect of Java, they couldn't add this as a library because yes, it would work on Mac, yes, it would work on Linux, would work on different flavors of things, but it wouldn't work on Windows. Now that Windows supports this, they've added it as a feature, and it's quite handy because the way that people would typically do this, if they didn't have access to this directly, was using a TCP/IP loopback connection, and that did effectively the same thing for inter-process communication, but it was not as secure and had lower performance. Now we just have the idea of simple Unix domain socket address, and we can use of as a factory method, provide a file name for where we want the endpoint of that socket channel to be, and then we can access our inter-process communication through that. Streams mapMulti. So when you read the description of this, it sounds very similar to flat map because it says each element on the input stream is mapped to 0 or more elements on the output stream. And I know when I read that, I thought, well, that's flat map, isn't it? So what's the difference? And the difference is that a mapping can be applied at the same time. So it's both doing an input stream from one to many elements, but also mapping at the same time. And it uses a by consumer to do this. So to give you some examples, you can do it 3 different ways, and only one of them actually makes any sense. What I mean by that, so you can do a 1 to 0 or 1 example. Take a stream of words, programming language names, pass it into mapMulti, and for that we have our by consumer, which takes the strings as input, and a consumer, which is what we're going to add things on the output. And then we can do a test. We can say if string.length is greater than 4, call the accept method on the consumer and pass in the length that we have. And if we run that and we print out for each element on the output stream what the length is, we'll get 6 followed by 10. Now, the reason I say this doesn't make any sense is because you can just do that with filter. It would be easy enough to do it with filter, and then that would work. Another one doesn't actually make any sense to use mapMulti for this, but I'm using it just to show you how mapMulti works. So you could do stream of with your names again of programming languages, pass it to mapMulti, use your string and your consumer, and then just call the accept method on consumer with the length, and that will give you the length as 4, 6, 10, 2, 4. Again, rather than using mapMulti, you just use map, and it does exactly the same thing. Where this does make sense is if you want to do something like this, where you want to do a 1 to many with a mapping. So now we'll take our programming strings and we'll pass them into mapMulti, our string and our consumer. And then this time what we're going to do is we're going to print out the number of letters in that each word, but print that number out the same number of times that it has those number of letters. So we'll print 4 times, 6 times, and so on. The most important thing about this is understanding that you can call the accept method on the consumer as many times as you like. So you're not restricted to just calling it once. You can recall it as many times as you like, and therefore you can replicate 4 times, 6 times, and so on. So that will basically do that. It's a small change, but it's kind of, I'm sure it will have some interesting applications. The Vector API. This is an incubator module, meaning it's not part of the Java SE specification. Again, it's one of these new things that allows you to test it out and provide feedback. What this is designed is not as the vector collection class that we've had right from, what is it, JDK 1.2 and was replaced by ArrayList. No, this is about vector computations, single instruction, multiple data. If you look at modern processors, you will have very wide registers, and you can load up multiple elements from an array, apply a single operation to all of those elements in a single clock cycle, and improve the efficiency of your numerically intensive operations quite well. The problem with this is getting the compiler to understand code that can use vector operations. And certainly if you make code reasonably complicated, the compiler will struggle a lot to understand, oh yes, okay, so you're doing this kind of thing, we could use a vector operation in this case. Ideally, this particular API wouldn't be necessary. If we had a compiler that was smart enough to spot these things, then we just leave it up to the compiler, the JIT compiler, to do all of this work for us. Let's look at an example. So what's happening here is we're doing a computation. We're using 3 arrays of floats. So we want to take the 2 as input and then generate 1 as output. So we'll basically iterate over the length of the array, assume that A and B are the same length, and we'll create a result C, which is A squared plus B squared times -1. For whatever reason, we're doing some kind of matrix manipulation. That's what we're going to do. Now, to enable the compiler to understand how to do that using vector operations, we can make it more complicated, but it gives us much more control over what's going on. What we do is, first of all, we need to define a species of vector operation. And this is where we, as developers, need to understand what hardware we're going to be running on. The species we're going to use, in this case, is 256. Meaning that if we're running on an Intel processor, that would typically be AVX AVX2 instructions because they're 256-bit wide. But you could probably also get away with using AVX512. But anyway, you have to understand what the hardware is you're going to be using, and so how big the registers are. If we rewrite our vector computation, what we're now going to do is we're going to create an index in range from that species that will enable us to index into the vectors that we're going to use to be able to populate them with the values that we need. So that's M. Then we create a float vector from the array, and we use the species. So we know it's 256-bit wide register. We know that the source is A. I is the element that we're going to read from that. M is the way that we're going to put it into that vector. And so we'll populate the vector with the elements that we're taking from the array. Do the same thing with the elements from B. And then what we can do is we can specify the numeric operation that we want to take place on that. And so we say VC, this is going to be our other vector that we're going to create, takes VA, multiplies it by VA, adds the value of VB multiplied by itself, and then we negate the result. So we're essentially doing the same thing that we do above, A squared plus B squared times -1. Now, interesting thing here is I wrote a blog article about all the new features in JDK 16, and I did make a comment about this particular feature, and I got some feedback from Brian Gertz on this, because I said that I really thought that, you know, it would be better if mul was multiply and neg was negate. I just thought that was a good thing, but you know, apparently it's still being thought through, so maybe it'll change at some point in the future. And then the result that we do is we feed it back into the array from C, to generate C as the array, and then we can get our results. Foreign Memory Access API. Again, this is something that was introduced back in JDK 14 as an incubator module. It's still an incubator module, and this is more to do with Project Panama, which is accessing native code from Java code without having to use the complexities of J and I. Foreign Memory Access API is a little bit more sort of broad in terms of its appeal, because what it allows us to do is have access to memory outside of the heap. So if we want to access native memory, we can do that. And there's three kind of fundamental parts to this. There's a memory segment, which is essentially a contiguous area of memory. So you can think of it as a pointer. You've got a memory address, which is also like a pointer, but in this case points to an individual location in the within the memory space. So the memory segment is an area of memory. The memory address is an individual address there. And then a memory layout is how we can describe what a memory segment actually holds. And I'll show you a little bit of an example of that. So we can do something as simple as saying, okay, we want an area of memory. So this is like saying, if we were writing C, we would malloc. So we say memory segment is a memory segment, allocate native 100. So we're allocating 100 bytes. So it's malloc 100 bytes, we get a pointer. Then what we do is we want to put ints into that area. So we take our memory access, we set int at offset, and we calculate the offset based on the number of the element that we want to put in there. So we're figuring out where to put it. Then we store the value at that address. So it's you know, it's a bit like native code. Using memory layout makes life a little easier, and we can do that by combining it with a var handle. So what we might want to do is to simplify what we had before, and rather than having to figure out that we're dealing with ints, so we know that they're 4 bytes, and then having to calculate the offset ourselves, we can create a memory layout as being a sequence of 25, and then we say that it's going to be 25 memory layout values, which are 32 bits wide, so they're ints for us, and we're going to use the byte order, which is the native order of whatever machine we're running on. So we don't care about whether it's least significant byte or most significant byte first. We'll just use whatever the machine uses. So that essentially creates us an array of 25 ints. Then we can create a var handle to access that. So we use if we say it's an int as a class, then we'll use path element to get the sequence of that. And then what we can do is we can again use a sort of try with resources block and say allocate me enough memory to store that array of integers, and then we simplify things a bit because we go, okay, we're going to go through our count, get as longs, and then store the information in there. Foreign linker API. Again, this is part of Project Panama, and this is a new incubator API in JDK 16. Works in conjunction with Foreign Memory Access API, and primarily or initially targeted at C native code, not necessarily C++ yet, but C++ should follow. What I have to say is that if you look at Project Panama, they have a JExtract command, which does a lot of this work for you, and it makes life a whole lot simpler. Sadly, that's not part of the JDK yet, but when Project Panama does get fully integrated, we'll see that as something that comes along. So what we now have to do at the moment is, if we wanted to use one of the system calls on our, let's say, Linux box, and we want to get the process ID of what the one that we're running, what we can do is, first of all, we need to get access to the C linker. So we use a static method on that, clinker.getInstance. Then we have to use a library lookup to find the particular function that we want to reference. And in this case, we're using the library lookup of default, meaning that we'll search for this library reference in all the things that are accessible from the JVM. And since the JVM is sitting on top of a Linux kernel, then it will be able to get access to a get PID system call. If we wanted something that was in a library that we had provided, a native library, then we'd have to use a different library lookup to find that library in a file and so on. But in this case, we're just using the default one. Then we need to get a native method handle for the getPID function. So we use the linker down call handle. Down call handle is where we're actually calling to the method in the operating system, in this case, or in the library. There's also an up call handle, which you would use for a callback from a native method to a Java method. So in this case, we're just calling down. So we'll call down to the library. We look up getPID, get the reference to that. Then we say that the method type is one that takes an int as a value. And the function descriptor, what it's going to return back to us is a C int. So we're passing an int from Java, and we're going to get an int back in terms of our method. And then we just invoke getPID, invoke exact, and we get the result of what we're looking for. Warnings for value-based classes. This is related to another bigger project called Valhalla, and Valhalla is all about adding value types to Java. So one of the things that they want to be able to do is to eliminate the need for the wrapper classes in terms of storing collections. So we could create an array list of ints rather than an array list of integer objects. Part of that means that they need to treat the primitive wrapper classes slightly differently. So they're going to, from JDK 16, they're designating the they're designating the wrapper classes as value-based ones. If you go back to JDK 9, you'll find that the constructors were deprecated for those classes. Typically, you wouldn't use those anyway. So you use things like auto-boxing and unboxing. You don't tend to call the constructors directly. So those were deprecated in JDK 9. They've now been marked explicitly for removal in it should be JDK 17. So you won't be able to use the constructors on those in JDK 17. Also, attempting to synchronize on an instance of a value-based class will issue a warning, because that would also be problematic for how Valhalla is going to work. A few other changes that have taken place. So these are things outside of the language and the classes. JVM type things. First is elastic metaspaces. Metaspaces was the replacement for the permanent generation that happened, was it JDK 7 maybe? I think it was. I can't actually remember when that one was. But anyway, the permanent generation got replaced with metaspaces as part of native memory. And now in JDK 16, those have become elastic, meaning that unused metadata memory can be returned to the operating system, reducing the footprint of the JVM. If it's long running, then you can actually give memory back to the operating system. The other thing around the ZGC, or ZGC as the Americans like to call it, what they've done is to improve the efficiency of how they do thread stack processing. When you start running most garbage collectors, they need to create a root set, which is a list of all the objects that are directly accessible from your application code. And how that worked in the past with ZGC was that they would actually have to pause all the application threads, reach a global safe point, and then go through and scan the stack or stacks, looking for the object references and building up the root set. What they've now done is made that in such a way that you can do lazy processing. It's more cooperative, concurrent, incremental, so there isn't the need for a global safe point, and it improves the efficiency of things a lot more than it was before. What they also did, which was interesting, was they made this a general approach rather than tying it to ZGC. They made it a general approach for garbage collection systems, and the developers of Shenandoah, Red Hat, looked at that and they said, "Oh, that looks really good. We like that. We'll bring it into ours as well." So they're using it. So it's a nice kind of reuse of code. Strongly encapsulate JDK internals by default. So this goes back to what happened with JDK 9 and the introduction of modularity. And one of the ideas of modularity was also to encapsulate the internal APIs, the ones that weren't part of the public Java SE standard or the JDK public ones, things like Sunmisk Unsafe. Now, back in JDK 9, that didn't happen because too many things like Spring and other frameworks were using some of these internal APIs. To get around that, they introduced the idea of the big kill switch, the illegal access command line flag. And that has 4 options: permit, warn, debug, and deny. And up until now, the default has been permit, meaning that you still have access to all of the critical internal APIs and you can still use them without any problem. What they've now done is turn that on to deny, meaning they've turned off the normal access. However, critical internal APIs are still not encapsulated. So there are 6 of those, and that includes Sunmisk Unsafe. Until they get a way of doing the functionality of Sunmisk Unsafe without having to use that internal API, they won't turn off access to that. Things like the foreign memory access API, that is something which will help remove the need for Sunmisk Unsafe. So at some point, it will disappear. Packaging tool. This was something that originally shipped with JavaFX, and then back in JDK 11, Oracle said they weren't going to include JavaFX with their JDK anymore, and suddenly people went, hang on, we don't have a Java packager tool anymore. To get around that, in JDK 14, they introduced that as an incubator tool so that people could try that out and use it without having JavaFX as part of the JDK. In JDK 16, it is now a final feature, so it's included standard. There will be no more changes to that in terms of its design. What it allows you to do is create a platform-specific package with all the dependencies you need for a given application. So if you're running on Windows, you can generate an .exe file, .msi file. On Linux, you can generate RPM files and deb files. And on macOS, you can produce PKG files or DMG files, which then automates the idea of installing a particular application on those platforms. The best thing to do with that is to combine it with the use of JLink. So you generate your tailored Java runtime, your JDK that's shrunk down, only the modules it needs for the application. That makes a nice, tidy, compact package for installation. To summarize then, basically, I think the 6-month release cycle is working really well. I think that the idea of the incubator modules, the preview features, the ability to get these things in, let people try them out, still have feedback on them is really good. And we're seeing a very much faster pace in terms of delivering new features to the language and the small things that people really want just to make their lives easier. And I think that when we get to JDK 17, because that's going to be the next long-term support release, which a lot of people will move to because they'll be able to use it in production, that's when we're going to see all the benefit of these new language features and so on really helping developers out. So it's really good in that respect. JDK 16's got some useful, interesting things like the vector API, replacement for JNI through the foreign memory access, foreign function API, all of those sorts of things, and some of these preview features now becoming full features as part of the standard, pattern matching instance of records and so on. If you're interested and you want a JDK to deploy into production, Zulu. And just since I work for Zulu, I will just tell you a little bit about Zulu Enterprise. Essentially, it's our build of OpenJDK source. It is fully TCK tested. We support all the way back to JDK 6. In fact, we support JDK 6, 7, 8, 11, 13, and I should add 15 there because we now also support 15 as what we call a medium-term support, same as 13. We backported TLS 1.3 and Flight Recorder to JDK 8. So if you want to use those, you can. And we provide wide platform support in the form of 64-bit Windows, Mac, and Linux, and 32-bit versions for Windows and Linux. And we've even got some things like Solaris on Intel and Spark. We've got some other sort of MIPS and PowerPC and various things like that, ARM64, that you can get from us. And it is very much a real drop-in replacement for the Oracle JDK. You just deploy it, and you don't need to change any of your code. So with that, thank you very much. So what I'm going to do now is I'll stop sharing my screen and go back to the...
Thanks.
There we go.
Thanks a lot for this talk.
I know there was a lot of information there. No, that's fine.
Okay, yeah. Thanks a lot for this great talk. That was really awesome. I'm really glad that you're on our conference. Thank you very much.
Okay, so I should join the Zoom call now, shouldn't I, for Q&A?
Just a second. Okay. Yeah, we have some time in our broadcast, so we have some questions which we may do in broadcast, and then we will start the discussions on Zoom. So, Zhenya, I pass the word to you.
Yeah, thank you so much, Simon. Thank you so much for this great talk. And before I'll start to asking several questions, we started polling on our Telegram chat, and according to this polling, the most loved features of JDK 16 are pattern matching and records.
Yes.
Also, people notify that GC or JVM improvements are fantastic, actually.
Good.
Yeah. By the way, which feature is the most loved for you? Which one do you prefer?
Oh, for me, easily it's records. I really like records. They're so useful in terms of reducing the amount of code for certain situations. To me, it's always been, I've never understood why having a tuple in Java has been such a struggle. I mean, I know there is one buried way down. There is actually a tuple class in the standard class libraries, and it's buried down somewhere. I can't remember where it is now. But just the idea of having a simple tuple class, why we never had that, and now we have records, which gives us a lot more flexibility on that. So that is definitely my favorite feature. I'll probably get into trouble with Brian Gertz again.
100% agree.
Yes, same for me. So yeah, and we are going to start with several questions. I believe we have some time. So first of all, does it even make sense to switch to Java 16 if 17 is just around the corner? Mm-hmm. So for most cases, it will mean that everybody will need to adopt 16th and 17th version.
Mm-hmm. Yeah, I suppose it depends to some extent on who you ask about that, because I think that if you're looking at deployment into production and what you want is stability for builds and being able to maintain updates, then waiting for 17 makes a lot of sense, because you can deploy onto 17, get all those features, and then you get extended updates for under the long-term support, depending on who you go with. You can still deploy 16, but what's going to happen is, if you want to maintain the security and the stability of those machines, once 17 comes out, you would have to then redeploy onto 17. So you either deploy 16 and then go straight to 17, or you just wait 6 months and then deploy onto 17. It really depends a lot on what the testing processes are for a given environment.
Mm-hmm. Thank you for your answer. Next one will be related to memory access feature. So does this memory access feature have something similar to Valhalla project, or it is some kind of another project?
Yeah, it's not so much the Valhalla project. This is, although you can define the structure of the memory areas that you're accessing, this is more part of Project Panama than it is Valhalla. Valhalla is more about defining value types, and so having the ability to treat either an int as an object, or being able to have specific storage underneath that reduces. So if you've got, for example, an integer object that stores 3, why have multiple instances of that? Because they're all storing 3. Just have one and everybody points at the same object. So that's more what value type's about. The memory access is more as I said, Project Panama, and the idea of being able to access both functions and memory outside of the JVM and do that in a simplified way, and replacing some of the functionality that we've got in Sunmisk Unsafe from a memory access point of view.
Thank you. And I have a question from my own side. So what do you think about Vector API, and will it be widely used? So current use cases you mentioned, but it needs to be adopted anyway.
I do wonder about that as to how much people will use it, because there are obviously situations where it can be very useful, but it does tie you very closely to the underlying hardware. So as I said, you've got to determine which species of vector operation you're going to use, and that means need to know in advance, are you going to be which version of the processor you have in terms of how wide the vector operation is, and so on. What I think is more beneficial, and I'll say this because I work for Azul, and so this is the kind of thing we do. What I think is more beneficial is if we can get the JIT compiler to be clever about interpreting what particular code can have vector operations applied to it. And one of the things we've done in our Zing JVM is replace the C2 JIT with what we call Falcon, is based on the LLVM open source compiler project, and that's much better at spotting where you can apply vector operations. So that example that I gave you, which is very simplistic, I think you probably find even C2 would be able to recognize that as a vector operation. But more complicated ones, our compiler will automatically detect, yes, you can use vector operations on that, and it will do the underlying code generation for you. So I think it's one of those things that there's probably some extreme situations where it makes a lot of sense, but it's probably not going to be a widely used API compared to many of the other ones. So yeah, that's my thoughts.
Yeah, thank you so much for your answers.
Yeah, thank you very much again for your talk. It was great, and it was a great honor to have you on our conference. So thank you again for joining us. I see a lot of thanks and other really warm words in our YouTube channel and Telegram chat. So thank you from all our audience. I just transmitted to you. So yeah, now we will have a Zoom chat, like Zoom discussion room with you. So guys and girls would be able to ask you questions like in more direct way. So this link now would be in Telegram chat and in YouTube. I already see it. So please join this session, and you will be able to talk with Simon more closely about Java features. And I saw a lot of comments in the YouTube about Kotlin, and that these features were in Kotlin for a long time. I'm not really agree with that, but you may discuss it with Simon more closely.
Okay, right. I'll switch to the other one.
Yeah. So thank you, Simon, Jenny. Thank you also for your moderation, and see you on another talks. Bye, guys.